All right, so we are applying, so we could decide whether it went both up or both down. We had a U either going up or an upside down U. Then we said, well, if I find my zeros, I could come up with a nice rough sketch of this, and I could actually solve inequalities with it. I could say, well, my graph looks like this. It's got zeros. It goes up. I know where it's above 0. I know where it's below 0. Well, we can apply everything we know for quadratics to even functions, and we can learn a little something new, and we'll do the same thing with odd functions. So we're just expanding what we did with quadratics, but to all polynomials. So the first thing we're going to start off with is what a polynomial is. This is what a polynomial is. It's the sum power where we have a bunch of numbers in front of it, i.e. 3x squared plus 4x plus 3. That's just what up here. All these are placeholders for that. So don't get confused by this equation. All right, graphs of polynomial functions. First of all, they're continuous. They're always going to be continuous. There are no holes or breaks. The second thing is they're smooth.
Just like me.
Smooth. Just like him. All right, smooth. What I mean by smooth is there's no jagged edges. When it turns, so picture a parabola. A parabola doesn't come down and go up like that. It's not like an absolute value. Smooth means that it just kind of, it wavers kind of like that. Like there's no quick jokes. It's very smooth around the edges. There's no actual corners or anything. Everything is going to be a smooth turn. So it's continuous, it's smooth. Now we're going to talk about something called the leading coefficient test. You've already done this. In fact, let's start with the even degrees because we already know this one. Even degrees, so I'm going to skip a slide here. We're going to go on to even first. Even is x squared. It is x to the fourth. It is x to the sixth. So our even degrees are just like x squared, x to the fourth, x to the sixth, so on and so forth. Well, let's look at x squared. Let's look at x squared. Yeah, make sure we're on the even. I'm on 2.
Oh,
Well, most of us knew. So picture an x squared graph. X squared either makes a U shape or it goes upside down. How do I know if it's U or if it's upside down? Yeah, Emma.
Positive and negative.
Positive or negative lead coefficient.
Yeah.
So that lead coefficient, that one that's out front, so that's what we have here. Our a sub n is our leading coefficient. If that is positive, it goes up. It makes a U shape. Well, with any even degree, we are going to at very least know if we have a positive lead coefficient, both sides are going to go up. I don't know what happens in the middle. Some craziness could happen in here. I don't know that for sure. But I know at least both ends go up. If it's x squared, it would connect into a U-shaped. If it was x to the fourth, it might do something like that. If it's x to the sixth, it might do something like that. But what I do know is that as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y also goes to infinity. Both ends go up.
is the thing before the X and
It's an as.
oh.
It's an as where I forgot the s and I kind of threw it in there. There we go. As x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to negative infinity. All right, if our lead coefficient is negative, it's just both going down. So as x goes to infinity, y goes to negative infinity. And for this one, didn't leave myself much room. Let's just put it over here. As x goes to negative infinity, y goes to infinity. Once again, these are just the ends. I don't know what happens in between. If this was a square, it might look like that. If it was to the fourth, it might make a W. If it was to the sixth, it might make a crazy thing like that, so on and so forth. But all I know is what the ends do.
If as x goes to negative infinity.
Oh, y goes to negative infinity. It didn't quite write in there. Hang on, let me get that negative in there. So, in other words, as I go left, y values go down. Yep, so as x goes to negative infinity, y also goes to negative infinity. All right, let's go to our odd then. If f is an odd degree would be x. It would be x cubed. It would be x to the fifth. It would be x to the seventh. Well, if our leading coefficient is positive, let's think of the most basic odd function, and that is y equals x. If I have y equals x, my leading coefficient is 1, and it's positive. I want all of us to picture what y equals x looks like. Looks just like that. Yeah, draw it with your hands. That is the end behavior of any odd polynomial with a positive lead coefficient. So what you probably just drew, let's go to a new slide really quick. What you should have just seen in your head is that. I hope. Well, that end behavior is going to be the same thing for any polynomial that has an odd degree. I'm going to draw my things like that real quick. So, going right is going to go up. Going left is going to go down. In other words, as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity.
Can you say that again?
Yeah. As x goes to infinity, so as x gets really big, y goes to infinity, y gets really big. As x goes to negative infinity, y also goes to negative infinity. Other words, as I go right, I go up. As I go left, I go down. All right, if we have a negative leading coefficient, that's negative x. Well, negative x is still going to be that straight line. It's just going to go the opposite direction. Well, if I know what that looks like, I know what the end behavior of a negative x cubed or a negative x to the fifth is. And that is as x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to negative infinity. In other words, as I go left, I go up. As I go right, I go down. Now remember, I don't know what's happening in between. I just know what the two ends look like. All right, that leads us to kind of 4 quick problems. Because all we're going to do on those 4 is we're just going to list what the end behavior is. So all we have to do in all 4 of those problems, locate your biggest degree, ask yourself, is it odd or even? And then do we have a positive or a negative lead coefficient? So the first problem says 2x cubed minus x squared plus 9. The biggest power is that 3. And that 3 is odd. Knowing that something odd means that our ends go in opposite directions. To figure out which opposite directions they go, we look at our lead coefficient and we go, is that positive or negative? Well, it's positive. So in my head, if I forgot what it is, I'm just thinking about y equals x. Y equals x is an odd degree, and I know what it looks like, and it's positive. Well, y equals x looks like this, so the end behavior is just going to look like that. Our biggest power in the next one is that 4, which is even. Even, either they both go up or they both go down. Well, 6 is positive, so they're both going to go up. So even and positive, they both go up. I don't know what happens in the middle. I just know that their ends both go up. That's all you need to draw. That's all I'm asking on this one. We're going to get a little more complex when we flip the side. We're going to know what it looks like on the inside. Our next one is 5x minus 7x to the fourth. Don't get thrown off by the 5x. Your biggest power is the 4. 4 is your biggest power, so it's even. Both up or both down? Which way is this one going to go? Yeah, down. They're both going to go down, yeah, because the coefficient in front of it is negative. So they're both going to go down. All right, the final one is odd. So that means one goes up, one goes down. Because it is negative, what I'm picturing in my head, if I forgot something, I'm picturing y equals negative x. Well, y equals negative x starts high and ends low. So as x goes to negative infinity, y goes to infinity. As x goes into infinity, y goes to negative infinity. All right, just like when we did quadratic, we started with end behavior, and then we filled in this area right here. That's what we're going to do next. We're going to fill in this area to come up with a rough sketch of what any polynomial looks like. All right. The first thing we're going to talk about is zeros of a polynomial. So for a polynomial function f of degree n, we know that the highest degree tells you how many zeros you have. Some of those zeros might be imaginary, though. So if we look at the function to the nth degree, it has, if we can't focus, we can take that test, okay? Oh, never mind. Never mind. That's for next week. Don't worry about it. I never said anything. No, because we have a borderline test next week. Okay, anywho, we have, the function has at most n real zeros. It has n zeros, so that means at most it can only have n real zeros. The graph has at most n minus 1 turning points. And what a turning point is, so a turning point is any time it changes direction. So this right here would be a turning point. This right here would be a turning point. Almost says turning point. And if you think about a basic thing, x squared. How many zeros does an x squared have if it hits the x-axis? 2. How many places does it change direction? 1. Our n was 2, so we could have 2 possible zeros, and we had 1 turning point. Where we find these zeros and where we do the turning points comes down here. And that is something called a repeated zero. We already talked about repeated zero. Repeated zeros are where you have a multiplicity. So when I say it's got a 0 of 2 with a multiplicity of 3 or 4 or 5. So a factor x minus a to the k, where k is greater than 1, yields a repeated zero, or in other words, a multiplicity of a specific zero. So let's look at the first case. The first case says, hey, if your multiplicity is odd, then the graph actually crosses at that 0. What example did I do? I did y equals, so we're going to do an example, y equals x minus 2 cubed. And that's good enough. All right, then let's look at our zeros. Our zeros at x equals 2. However, x minus 2 cubed is x minus 2 times x minus 2 times x minus 2. That means you can put that 2 in 3 different places. So it is x equals 2 with a multiplicity of 3. That multiplicity is odd. If your multiplicity is odd, your graph actually goes through that 0. You have two possibilities. Either the 0 goes through it or it bounces off it. This is going to go through at 3, so it's going to look something like this. I don't know what the whole graph looks like, and we'll get to that in a second, but I'd count out 3. This graph would actually cut through at 3. It actually goes through at 3. Yes? 2, yes, 2. Ah. Oh, no. Oh, no. My original example was through 3. I think I just went on autopilot. All right, yeah. So it would actually go through. I got him.
You're a plane.
It's a metaphor.
So it's going to go through at 2. I am not a plane. Our next one says, if k is even, then the graph is tangent or touches to the x-axis at x equals a. So let's do almost the exact same example. Let's look at y equals x minus 2 squared. We're going to do x minus 2 squared. Well, that has a 0. Once again, the 0 is at x equals 2. But this time we have a multiplicity of 2. That multiplicity is even. So it says that it's tangent. What it means by tangent is it just bounces right off it. It reaches it and bounces right off it. So in this case, if I draw my graph, we'd go to 2. And this is going to come down, bounce right off it, and go up. 2 is still a 0. It just bounces off it. It touches it and goes back up, or whatever direction it's going. So now we have n behavior. Bless you. And if we can find our zeros using factoring, we can actually get a nice rough sketch of our graph. So let's go ahead and do that in the next 2 examples. You should have a lot more room than I do. So what I'm going to do is I'm going to do my work and I'm going to end up in this box. You should not end up in this box. Everything I'm doing should end up below it. All right?
I don't know what that means.
It means stay in this box. I know you're joking, but people will go to this box because you just write what I'm writing. All right. Long story short, we're going to stay in this box. All right. Whenever we have a polynomial, the first thing I want to do is I want to know what happens at our ends. I want to know what happens when I go to negative infinity in our x value. I want to know what happens when I go to positive infinity with my x value. So we're going to do our lead coefficient test. Our lead coefficient test, you just have to look at your biggest power and the coefficient in front of it. So our biggest power is this x cubed. Well, x cubed is odd power, and it has a positive 1 in front of it. So our graph, although I don't know what happens in between, because it's odd and is positive, is going to start low and it's going to end high. And then we're going to use the zeros to figure out what happens in between. All right, so we need to find all our zeros. The only way for this to work is for us to be able to factor it. So any problem where I have you saying you have to graph these polynomials, do a sketch of it, they're going to be factorable. This one we can see automatically is the start of it's factorable because I can factor an x out of every bit of it. So we're going to rewrite this as f of x equals, and we'll factor an x out, so we'll have x. We'll have x squared plus 2x minus 3. Then based upon what I just said, it should be factorable the rest of the way. So we should have an x and x. I'm looking for 2 numbers that multiply to give me 3. The only thing that works is 3 and 1. It's got to come out when I add them together be positive, so we're going to have a positive 3 and a negative 1. All right, so I have 3 possible zeros. My first 0 is, hey, x could equal 0.
Yeah.
My next one is x is going to equal negative 3. And my last one is x equals 1. In order for us to know what it looks like, I have to know if it cuts through there or if it bounces off. So you have to look at the multiplicity of them. So what you're going to do is you're going to look at the powers that are attached to it. So x to the first, x plus 3 to the first, x minus 1 to the first. Those are all odd multiplicity. In other words, x to the 0 has a multiplicity of 1. X minus 3, x equals negative 3 is a multiplicity of 1. And finally, x equals 1 is a multiplicity of 1. If you have a multiplicity of 1, it crosses. So all three of these are odd. So all three of them are going to cross at those given points. One more time. You guys are staying in this box because you should have room. I am going to go over here to graph this. So to graph this, we are going to look at our zeros. We have a 0, we have a negative 3, and we have a 1. So we have to go negative 3 in this direction. And I'm going to put a point at negative 3. I also have a point at 0, and I have a point at 1. All right, now I'm going to use my leading coefficient test, which says I start off low. So we're going to start to the very left of our leftmost point at our low point. And as I come up, this is where I ask, does it bounce off or does it cut through? Well, since it's odd, it crosses through, so we are actually going to go straight through this. Now, a polynomial is smooth with curves, so it has to make its way back down to this 0. So we're just going to go up and then come back down to this 0. Now, as I approach it, I'm just asking myself, does it bounce off or cut through? We said all of them are going to go through, so that one's going to go through. This one's going to go through. And as soon as I'm done, I'm going to make sure my end behavior made sense. I started low, and I ended high. So more than likely, I got the crossing and bouncing correct. Yes?
Will we ever learn how to graph that top and bottom, like the turning point?
Like perfect?
Not perfect, but like get that point.
You could plug in that point. So we could get the halfway point between these two. That's your x value. Plug it in, you can get that exact value.
Okay.
There's no real need. It's barely ever needed that you have the exact graph of this. I just want to have something like this so I can go. So if I put this equation, I said, when is this less than 0? We could just highlight and get all those values. And I can get a general idea of where my maximum was. So if I said, what point is this? We have a good idea where that would be. So the drawing, it really can key. I think you guys can plug in points and do that stuff. We're not going to get too much into that. This is about as far we're going to go with it. But can you see, it really isn't that hard to get a more exact. It's just plot one point, and then you know where the maximum is. I would pick a point between 0 and 1.5, plug that in, and I would actually have this distance on here. Plus, we have calculators. I just want you guys to be able to just look at something and generally know what the shape is without having to go to a computer and plug it in. That's the goal. All right, guys, I want you to do the next one.
It's like real big numbers.
The one in the box?
It's not a real big number.
The one next.
The one next to it. So as we erase. Well, we can actually start this together. Let's start it together. Just because it's x to the 4th. We know it's factorable because I said it's factorable. Which means to get x to the 4th out, I would need x squared and an x squared. Because x squared times x squared is x to the 4th. X squared plus x squared is still x squared. So we covered the x to the 4th and the x squared. Now I'm looking for two numbers that multiply together to give me 10,000. But when added, they equal negative 200. Mary? Negative 100.
Wait, wouldn't
Is right.
it have to go like to 10,000x and then something else after that? Because like we're missing a 0x. How does that factor in?
Why are we missing a 0x?
3x cubed. Oh, and the x.
Oh, Oh yeah, x cubed too.
Why are we missing x cubed?
It's not there.
It's just not there.
That's okay. There's 0 of them. There's 0 x cubes.
Okay, so it doesn't factor into that at all.
Well, if you went ahead and distribute this, I bet you any money you get this out.
Okay. Alright.
If you don't believe me, do the multiplication.
I believe you. I believe you 100%.
Well, what's x squared times x squared? What's x squared? X to the 4th. What's negative 100x squared plus negative 100x squared?
I believe you.
Answer the question.
Okay.
It's
Negative 200x squared.
what's negative 100 times negative 100?
10,000.
10,000.
Pencil that.
So we have 0 x cubed, so I don't need to throw an x cubed in it because I feel like it needs one.
Okay.
If it doesn't have one, we leave it out. All right, we do have to go a little further though. We do have to recognize that this is a difference of squareds because 100 is 10 squared and this is
No way.
10 squared. So a difference of squares would boil down to x plus 10 times x minus 10 times x plus 10 times x minus 10. I want you to finish this off. Double check. You should have a W shape because it was supposed to bounce. We would have negative 10 multiplicity 2 and we'd have a positive 10 multiplicity 2. Both would be tangent, bounce off. Here would be your graph.